Namaste everyone, and welcome back to our Java programming tutorial series. I am your instructor, and today we are diving into a very important and often misunderstood feature in Java, the optional class. Have you ever encountered the dreaded null pointer exception? It is often called the billion-dollar mistake because it causes so many errors and crashes in applications. Well, Java's optional class is here to help us write cleaner, more robust code by explicitly indicating when a value might be absent. In this 5-minute tutorial, we will understand what optional is, why it is useful, and how to use its core methods effectively. By the end, you will be able to write Java code that is much safer from unexpected null values. Let us begin our journey to master the optional class. Alright, let us start by understanding the problem that optional aims to solve, the null pointer exception. Imagine you have a method that searches for a user by their identification number. If the user is not found, this method might return null. Now, if another part of your code tries to access properties or call methods on this null reference without first checking if it is indeed null, boom, you get a null pointer exception at runtime. This can be very frustrating to debug and can lead to unstable applications. Traditionally, we would add if user is equal to null checks everywhere, which can make our code verbose and less readable. The optional class provides a more elegant and expressive way to handle these potentially absent values, encouraging us to think about nullability upfront. Let us see how it does that. Now, how does optional help us? Think of optional as a container that may or may not hold a non-null value. It is like a box that either has something inside or it is empty. To create an optional from a value that might be null, we use the static factory method optional.ofNullable. If the value passed is non-null, optional.ofNullable returns an optional containing that value. If the value is null, it returns an empty optional. Once you have an optional object, you can check if it contains a value using the isPresent method, which returns true if a value is present and false otherwise. This clearly communicates to other developers that this value might be absent, forcing them to handle both scenarios explicitly. This simple step prevents many null pointer exception issues. So, you have an optional, and you know a value might be present. How do you get that value out safely? The get method will return the value if it is present, but be careful. If the optional is empty, calling get will throw a no such element exception, which is just as bad as a null pointer exception. A safer approach is to use or else. This method allows you to specify a default value that will be returned if the optional is empty. Even better is or else get, which takes a supplier functional interface. This means the default value is computed only if needed, improving performance for expensive default value calculations. For example, if you are creating a new object as a default, or else get will only create it when the optional is empty, unlike or else, which would create it every time. Choose wisely based on your needs. Optional truly shines when combined with Java's functional programming features. You can chain operations on an optional using methods like map, filter, and if_present. The map method transforms the value inside the optional, if it is present, returning a new optional containing the transformed value. If the optional is empty, map simply returns an empty optional. The filter method allows you to apply a condition. If the value is present and matches the condition, the optional is returned, otherwise an empty optional is returned. Finally, if present lets you perform an action on the value only if it is present. These methods enable a fluent and expressive way to process values without explicit null checks, making your code cleaner and more concise. Alright, we have covered a lot about the Java optional class today. To recap, optional is a container object used to represent the absence or presence of a value, helping us avoid null pointer exceptions. We learned how to create an optional using of-nullable check for presence with isPresent and safely retrieve values using or-else or or-else-get. We also explored its powerful functional methods like map, filter, and if-present for chaining operations. Remember, while optional is a great tool, it is not a replacement for every null check. Avoid using optional as a field in classes or as a parameter in methods. It is primarily designed as a return type for methods that might not have a result. Practice these concepts, and you will write much more robust and readable Java code. Thank you for watching. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more Java programming tutorials. Keep coding, and I will see you in the next video. Dhanyavad.